In this video, we will be talking about Azure databases. A persistent data store is at the heart of many applications. As you migrate existing applications to the Azure cloud or create new applications, you will likely find yourself needing to interact with a database. The Azure platform provides several options from which to choose. You can choose from relational database offerings such as Azure SQL Database, SQL Server running in the Azure virtual machines, or non-Microsoft databases such as Oracle or MySQL, or if a non-relational or NoSQL database fits your application needs better, services such as DocumentDB and Azure Table Storage might be a good fit. Furthermore, with Azure virtual machines, you can install a wide range of database platforms. Later down the road, we will refer back to them in the Azure Virtual Machines project that we talked about in the previous videos. When the time comes to determine a data storage approach for your application, the Azure platform offers a variety of database choices, enabling you to balance reduced friction and management with fully customizable virtual machines. Azure SQL Database provides a relational database as a service, targeted at online transaction processing or OLTP, that is, data entry and retrieval transaction workloads. This falls firmly under the platform as a service category of cloud computing. Using SQL Database enables you to give up the physical management responsibilities of a database server but retain the vast majority of logical management and administrative responsibilities. SQL Database provides many attractive features such as elastic scale, predictable performance, business continuity, near zero maintenance, and the use of familiar development languages and tools, each of which could help you have a better cloud service and provide better cloud service to your customers or your enterprise. It is very important to understand that with SQL database, you do not get a physical server that you can manage, because SQL database is a database as a service. And this, if not being remembered, may cause a lot of issues in managing the entire Azure subscription of yours. The underlying physical implementation details are outside your control. There are still logical services when working with SQL database that you can take advantage of, but these are not the same as Microsoft SQL servers you may be used to working with on premises. More will be included later in this video when we discuss administration of the Microsoft Azure. SQL Database is available in two different yet similar models: elastic database pools and single databases. Elastic database pools enable you to manage multiple databases in a pool, scaling performance up and down as demand changes while maintaining a predictable budget. One of the key features of the elastic pool model is the ability to share performance across many databases in the pool. Alternatively, if you have only a handful of databases, the single database model might be more appropriate for you. Both models allow you to adjust performance as necessary with no downtime and provide a 99.99% service level agreement as Azure actually provides. Both elastic database model and single database model are available in three service tiers: basic, standard, and premium. Within these tiers, performance is expressed in database throughput units or DTUs. A DTU is a synthetic measure that allows a quick comparison of the relative performance of the various database tiers. Within each tier, there are also performance levels. For standard, there are S0, S1, S2, and S3, which these performance levels provide a way to increase or decrease the DTUs available within that tier. The maximum database size will vary across tiers, ranging from 2 gigabytes to 1 terabyte. Look at the table on this slide, which lists some of the pertinent details for each of the database tiers. As you can see, for the service tier basic, there are no definition for specific performance levels. However, we know that the maximum database size in the basic tier will be 2 gigabytes, and there are 5 DTUs available. The target usage scenario for the basic tier is small databases with minimal concurrent operations, typically development or test usage scenarios. For the standard service tier, we go from S0 to S3, covering 4 different levels of performance. The maximum database size in this tier will be 250 gigabytes, while the DTUs can go respectively to the S0, S1, S2, S3, all the way up to 10, 20, 50, and 100. The target usage scenario for this tier is cloud applications with multiple concurrent transactions, which is most commonly used in the applications we have these days, and we have it on the mobile development tiers. The other tier is the premium tier, which uses the performance levels of P1 to P11, P2, P4, and P6 in between. For P1, P2, P4, and P6, the maximum database size will be 500 gigabytes or half a terabyte, while P11 uses 1 terabyte of maximum data size. The DTUs respectively go up from 125 to 1750. P1, 125, P2, 250, P4, 500, and P6, 1000 DTUs, while P11 maxes up to 1750 DTUs. The target usage scenario for this tier, the premium tier, is mission critical, enterprise grade, and any type of application that needs high transaction rates and advanced business continuity features. Note that web-based business editions for SQL database were retired in September 2015. There are more information about this retirement available on docs.microsoft.com under azure.microsoft.com. Determining which service tier to use often depends on monitoring and what you want to do with your application performance, and then adjusting SQL database tiers responsively. You can start with a basic tier based on the performance indicators and then scale up to a standard or premium tier only if needed. Remember, the higher in the tiers you go, the more money you pay for the service you provide. Integrated tools such as database advisors, formerly known as index advisors, or Query Performance Insights, or Query Restore can help you gain a better understanding of how to best tune either the application or the database you have. Adjusting service tiers and performance levels is an online operation, so you can continue to use the database while the operation completes. When doing so, some database connections might be dropped. Be sure to include retry logic in your application to be resilient to such transient errors. If you are migrating an existing on-premises Microsoft SQL Server database, you can use a third-party tool, and those tools such as SQL Database DTU Calculator are available online, some for a fee and some free. You can also use these tools to estimate the performance level and service tier needed for SQL database instance. Tools like SQL Database DTU Calculator works for both single and elastic databases, providing recommendations and DTU requirements while this tool is free. If you want to download this tool, you can go to http://dtucalculator.azurewebsites.net and get it from there. You can also find more information regarding the possibilities and the tools available on azure.microsoft.com under documentations. It is important to understand the relationship between a SQL database server and a database. When you create a SQL database server, you're creating a logical server that hosts a tabular data stream or a TDS endpoint. TDS is the same communication protocol that's used in Microsoft SQL Server. The logical server endpoint is identified by a URL, for example, contoso.database.windows.net. Each logical server can contain 0 or more SQL database instances. Creating a new SQL database is a quick operation. To create a new SQL database using Microsoft Azure, you can simply go to the portal and start creating that. From the portal, select the SQL database option. This will open a new blade that provides an overview of SQL database, along with links to additional helpful information. Clicking the Create New Database button will open a new blade, as you can see on this slide, which is going to allow you to configure key information for your SQL database. Let's take a look at what you can actually set up over there. On the SQL database blade, you can enter several key pieces of information, including the following. Name is what provides the name for the new database. Server, select an existing SQL database server or create a new server. When creating a new server, you will be able to provide the server name, for example, contoso.database.windows.net. The administrative login and password also could be provided. You can also check and choose the Azure region. Then you have the source, where you can select the source for the new database. It could be a blank or empty database, a restore from a previous database backup, or a sample AdventureWorks LT database. Then you have the pricing tier, which basically selects one of the available service tiers that we discussed earlier, basic, standard, or premium, and associated performance levels. Then you have the collation, which is a set of collation used for rules related to sorting and comparing data. You also can choose a resource group, select an existing resource group, or create a new one where the SQL database will reside in. Resource groups are helpful for grouping related Azure resources. And then finally, you have the subscription, where you have to select the desired Azure subscription, whether that's your free subscription or that is your pay-as-you-go subscription. When finished, click Create, and it might take a few minutes for Azure to provide the new SQL database. If you're creating a new database on an existing server, the new database likely will be ready in a matter of few seconds. Remember, as we discussed before, the maximum size for SQL database instances is 1 terabyte at the P11 level. If your data needs to exceed the capacity of a single database, you will need to use an alternative strategy to persist the necessary data. One such strategy is to spread the data across multiple databases, a process referred to as database sharding. The ability to create new database shards quickly allows you to elastically scale. Application owners can decide how and when to create a new database shards to scale out quickly, thereby enabling an application to scale out across multiple databases. One of the attractive features of SQL database is the near zero maintenance that it provides. Microsoft handles all patching, server configuration, load balancing, and database platform upgrades automatically. Additionally, SQL database handles management of system tables and file groups automatically. You're required to perform common administrative tasks such as managing logical aspects of the database, including logins, tuning index, and query optimizations. When using SQL database, you can use the same tools, programming languages, and frameworks you are accustomed to using with the SQL Server. SQL database and SQL Server are familiar in many ways, although not every SQL Server feature is available in SQL database. However, the two to share one very important feature. Both use TDS as the client protocol. This allows tools such as SQL Server Management Studio or SSMS to connect to the SQL database as they connect to the SQL Server. Before you can connect to SQL database from any tool, including SQL Server Management Studio, you will need to adjust firewall settings. SQL database is pre-configured with firewall settings that will explicitly deny access from any IP address, even those originating from within Azure. When creating a new SQL database server in the Azure portal, the default is to allow any Azure service, such as your Azure web app, in the Azure subscription to access the server. You can see this in the slide. It is generally not recommended to allow server access via firewall rules to all Azure services. Instead, it's recommended to enable access to only specific IP addresses that require access. To access the SQL database server from outside Azure, for example, from SQL Server Management Studio, you will need to modify the server firewall to allow access from the desired IP address or any range to access. From SQL Server Blade in the Essentials section, if you click on Show Firewall Setting links, what you see on the slide is going to be showed up, and that's where you can actually set up the below set configuration. Doing so opens a new blade that allows you to manage various aspects of the SQL database server and the firewall settings. On the firewall settings blade, you can enable or disable access to the server for Azure services or provide rules to allow access to the server from a specific IP address, including your specific client IP address. If you are hosting other services in the Azure, such as Azure Web Apps or cloud services that need access to SQL database instance, you will need to allow access to Azure services turned to on. Once you have added your IP addresses to the list of allowed IP addresses, you need to open SQL Server Management Studio. You will need to know the full name of the SQL database server before you proceed at this point. You can find the full server name and the essential sections of the SQL database blade along with other key information as it is shown on the screenshot at this place on the slide. When the Connect to Server dialog box in SQL Server Management Studio open, as you can see it here, enter the full server name and select SQL Server Authentication and provide the administrative login and passwords. When you do so, you basically enable your SQL Server Management Studio to connect to your Azure SQL Server database. Note that it is also possible to connect to SQL database by using Azure Active Directory authentication, thus providing a centralized location for management of database users and other Microsoft services. We will discuss this furthermore when we actually talk about Microsoft Azure Active Directory services on the other video. Now let's talk about the billing. Because SQL database is sold as a service, there is not a separate SQL Server license like you might find with on-premises SQL Server or with SQL Server in an Azure VM. Instead, you're charged per hour based on the highest SQL database service tier and performance level used during the hour. Recall, you can change this at any time. For example, if you start at 3 p.m. with an S1 at 3:20, you change that S1 to S3, you're charged the S3 rate for the entire hour. The pricing change becomes effective when the change in the tier or performance level is completed. So it may be a little bit confusing, but as long as you remember, you will be charged for the highest possible rate during the amount of usage. Then you know that you should not switch to any higher rate unless you really and necessarily need that. In addition to understanding how SQL database is priced, it's important to understand how many databases you can get. After all, the number of databases you have will directly affect the price you pay. By default, you can have up to 6 logical SQL database servers per Azure subscription, which each server can host a maximum of 5,000 databases and 45,000 DTUs. The default limits are soft limits, as most of the other limits within the Azure service and subscriptions, and they can often be raised by submitting a support ticket with Azure support. When planning capacity for a SQL database logical server, it is important to note the specific SKUs. They can be S0, P1, and so on. Each SKU has associated DTUs. The DTU capacity is actually the real time and real limit on the maximum number of databases supported. As performance is highly workload dependent, it is important to test your solution thoroughly and don't assume that 5,000 databases on a SQL database server will all perform equally well with no problem. So, when you choose the SKU, make sure that specific SKU is actually providing the maximum number of DTUs you need to move on with. SQL database provides several options to address business continuity requirements. One way in which SQL database provides protection is through infrastructure redundancy. At any time in an Azure data center, there could be a hardware failure, such as hard drive, network, or even entire server. SQL database provides high availability in the case of such hardware failures by keeping copies of the data on physically separate nodes. 3 database nodes or replicas are always running, 1 primary replica and 2 secondary replicas. For write operations, data is written to the primary and one of the secondary replicas before the write transaction is considered complete. In the event of a failure of the primary replica, SQL database detects the failure and fails over to a secondary replica. If needed, a new replica is then created. Furthermore, business continuity with respect to databases often includes 2 categories: database recovery and disaster recovery. Database recovery refers to ability to mitigate risk and recover from database corruption or an unintentional modification or deletion of the data. To assist with database recovery, SQL database provides a feature called point-in-time restore. Point-in-time restore allows you to restore a database to any previous point. The time frame from which you can restore varies based on the selected SQL database tier. It is 7 days for basic, it is 14 days for standard, and finally it is 35 days for premium tier. To restore a database to a previous point, first you need to select the desired database in the Azure portal and then click on the restore as you can see it in the screenshot in this slide. Clicking the restore button opens a new blade as shown on the right side. This allows you to enter the name for the restored database or keep the auto-generated default name and the restore point, which is date and time and at 1 minute intervals. The restore operation might be a long process. It may take a very long time to complete. The exact time to restore can be difficult to predict because it depends on several factors, including the size of the database, the restore point in time selected, and the activity log that needs to be replayed to get to the restore point. For some large databases, this process could take several hours. If you have selected a database, you can restore the entire database. To do so, first select the SQL database server that contained the database and then select the deleted database in the operations group of the SQL Server blade. This opens a new deleted database blade as you can see on this slide. If there are multiple deleted databases, select the database to restore. On the resulting restore blade, provide a name of the database to be restored, as shown on the slide. The database can only be restored to the point at which it was deleted. After you click Create, the restore request will be submitted, just like a point-in-time restore. The process to restore a deleted database could take a long time to complete. It can even go all the way up to the hours and hours. Point-in-time restore is helpful when you need to recover a database to known good point, which is often as a result of an error. These errors mostly are user errors. However, this is only one aspect of business continuity that Microsoft Azure provides. The other being disaster recovery. Disaster recovery refers to the ability to restore operations to a working state in the event of a disaster renders the primary region unrecoverable or unavailable for an extended period of time. SQL database provides additional features that can be helpful in preparing a disaster recovery plan. That is actually the GEO-RESTORE, standard GEO-REPLICATION, and active GEO-REPLICATION. Let's take a look at these options. The GEO-RESTORE in Microsoft SQL database allows you to restore a SQL database from a backup to any SQL database server in any Azure region. The time to restore will vary based on the size of the database, performance level, and number of concurrent restore requests in the target Azure region. Both point-in-time restore, as discussed earlier in this video, and GEO-RESTORE are possible because SQL database automatically creates backups of every database. Full backups are performed once a week, differential backups are performed once a day, and transaction log backups are created every 5 minutes. The backup data is persisted in Azure Blob Storage or RAGRS in a geo-redundant paired region. For example, East US and West US, North Europe and West Europe, as you can see it on this slide. To restore from a backup, you will start by following the same steps you would if creating a new SQL database. Instead of choosing the source database to be blank or a sample, you will select the backup option. Selecting backup as the source will enable you to then select one of the available backups, as you can see on this slide. Complete the remaining sections by entering the desired new database name, target server, either select an existing one or create a new one, resource group, and other information, and when you click on create, then your backup will be restored to this new option that you just chose. Next option is standard geo-replication. It is available for standard and premium databases. And through using standard geo-replication, you are enabled to create a single offline secondary database in the paired region of the primary database. The secondary database is unavailable for client connections until the region hosting the primary database fails, and then the secondary database is charged at 75% of the primary, which will be then turned into the primary and being charged at 100% of the fee. Note, in April 2016, Microsoft announced the retirement of standard geo-replication effective in March 2017. Therefore, as of today, the standard geo-replication is not available to the new subscribers after March 2017. This slide only comes for your information so that you have a full understanding on all the options available for the disaster recovery within Microsoft. So let's move on to the next, which is the active geo-replication. Active geo-replication, which is available for all database tiers, enables you to create up to 4 readable secondary databases across multiple Azure regions. It is up to you to determine when to fail over one of the secondary databases, which is unlike the standard geo-replication that we discussed earlier. Each readable secondary is charged at the same rate as the primary. As you remember, when we were talking about standard geo-replication, we talked about the secondary database is charged at 75% of the primary, while the active geo-replication charges the exact same rate. To enable a standard or active geo-replication, you have to use the Azure portal and select the desired database. From the geo-replication group or the link available under geo-replication role in Essential section shown in the next slide, you will be able to see a map displaying any existing secondary database or an option to configure geo-replication if none has been configured yet. Then select the geo-replication part displaying on the map to open a new GeoReplicant blade. On this blade, you can view all of the potential secondary locations and then select the desired location of yours. Note that for a standard database, only the paired region will be available, while for a premium database, you can select from any of available locations in the world. Click the location in the map, as you can see here, or select from the list of target regions displayed on the blade. This will open a new Create Secondary blade to enable you to configure properties related to the secondary database, as you can see here on this slide. In addition to using the Azure portal to configure geo-replication, it is possible to configure geo-replication using the Transact SQL or T-SQL. Also possible to use PowerShell or a REST API. You can find more information about T-SQL, PowerShell, or REST API online. For standard geo-replication, the secondary type will default to non-readable only. For active geo-replication, the secondary type will default to readable, and you will be able to select from multiple Azure regions. Now let's talk about some design considerations when it comes to setting up and designing your database. You'll need to familiarize yourself with several important concepts when determining which SQL database business continuity feature is for you to use. The business continuity features for SQL database across the service tiers, including RTO and RPO, are described in this slide and also are depicted in the table. So before going there, let's move over some of the terminologies for this table. We have estimated recovery time or ERT, which indicates the estimated time needed before the database is fully available after a restore or failover request. Recovery time objective or RTO indicates the maximum downtime before the application is functional after a disaster. And then recovery point objective or RPO indicates the maximum amount of recent data loss in terms of time before the application is functional after a disaster. Considering that information, look at the table and see how business continuity features every single one of those is going to help you. This table compares different business continuity features for you while considering different tiers within those features. Look at point-in-time restore. As you can see, basic tier keeps last 7 days, standard tier keeps last 35 days, and premium tier does the same. For GEO-RESTORE, ERTs are less than 12 hours in the basic, while they can go same all over the tiers. Same story is with RPOs. As you can see, all over the tiers, you have the RPOs less than 1 hour. And finally, when it comes to active geo-replication, as you can see, we don't have that available for basic and standard tier. Everything goes to the premium tier, where the ERTs less than 30 seconds and RPOs less than 5 seconds are available to you, which makes this tier a better option if a mission critical application is relying on the database that you are holding. It is important to understand that the ERT and RPO values provided above are not actually part of the official service level agreement for SQL database. They are engineering goals, and they're only provided as guidance for planning in the engineering and coding. There is no guarantee that these exactly happen. You can see the guides online on azure.microsoft.com under documentation and figure out what is the current service level agreement. Microsoft provides 99.99% database connectivity service level agreement for basic, standard, and premium tiers. The service level agreement only applies to being able to connect to the database, not to any performance targets with respect to the various tiers. I'm repeating this sentence, so please listen carefully. The service level agreement of 99.99% only applies to being able to connect to the database, not to any performance targets with respect to the various tiers. Next, let's talk about applications connecting to SQL database. When writing applications that need to connect to SQL database, you can use popular programming languages such as .NET, PHP, Java, and many more. Entity framework, sharing with .NET Framework 3.5 Service Pack 1 is also supported with Microsoft Azure. One of the first things you'll need is the connection string. You can obtain the connection string from Azure portal by clicking the Show Database Connection Strings link in the Essentials group for the desired SQL database instance. Remember, this basically is the key for your code to get connected to the Azure SQL database. So when you click on that instance, it opens a new database connection string blade, as you can see it on this slide, that displays the connection string in multiple formats, including ADO.NET, PHP, JDBC, and ODBC, which works for Node.js applications, no matter which version they're from. The connection strings for SQL database are similar to what you would use for SQL Server. For example, for ADO.NET, the connection string format could be anything like server equals TCP, and then your database server name comes in the curly braces, and the rest of information comes after that. Note that the connection string sets the trust server certificate property to false and the encrypt property to true. This is to provide additional protection while accessing SQL database over the internet. Doing so helps thwart potential man-in-the-middle attack or any type of crazy attacks. SQL database will force the connection to be encrypted regardless of the setting. When writing code against SQL database, it is important to defend your code against transient errors. Transient errors are errors that are intermittent and likely will be resolved if the command is retried. These errors are more common with SQL database than with the database accessed via a local area network. This is due to the inherently unreliable network that is the internet, and the fact that as a managed service, SQL database might periodically undergo maintenance activities that could cause connections to drop temporarily. Applications should plan for and defend against transient errors by incorporating retry logic when creating any type of connections or queries or executing commands against SQL database. From whatever caused the initial failure, no matter what it is, you have to be sure to choose a retry strategy that provides sufficient time for the platform to attempt to recover. So if you send your retry just within a second from the first failure, then you most possibly are going to receive a failure again. So you should let the database on the Azure to recover from that issue before you send the retry. So it could be said that if the database is not yet recovered from that error, your retry does not saturate the platform with the rapid succession of retry attempts, and it will have a maximum number of retry attempts and or retry durations filled to the max, and therefore you may create issues for your own database. For example, an exponential back-off approach with a preset maximum number of attempts is often suitable to be set in your code. Set your code to send the first message. If it didn't come back successfully, wait for 2 seconds and send another one. If the second one didn't come back successfully, then this time wait for 4 seconds and send the other one, and respectively wait for 8 seconds, wait for 16 seconds, and so on. Any type of strategies like this can make sure your retry logic is as effective as it should be, and it's not going to flood the network with the retry requests. For .NET applications using Entity Framework Entity Framework 6 contains connection resiliency or connection retry logic that will detect transient errors from SQL database and retry the command appropriately. For other .NET applications, Enterprise Library 5 and 6 from Microsoft Patterns and Practices contain an application block called the Transient Fault Handling Application block, which could be used in order to handle this retry requirement for resiliency. There is much more to the designing resilient cloud-based application than just implementing basic retry logic. It may also be necessary to reconsider how an application processes the data. For instance, it is often helpful to implement an eventually consistent solution, potentially using queues and background tasks to complete the requests. It may also be worth considering breaking read and write operations across separate databases, potentially using the active GEO-replication feature in the SQL database to replicate operations on the write database to the read database. Next, let's talk about SQL Server in Azure virtual machines. So far, all that we talked about was receiving the database as a service. Now, we want to go back to infrastructure as a service and how a database, how a SQL server within those could be implemented. Although SQL database provides database as a service with enterprise-grade features and virtually no administration, there are still situations in which running your own SQL Server deployment may be necessary. A common reason is the requirement to use features that are not available in the SQL database yet. As discussed before when we were talking about Azure Virtual Machines, Azure Virtual Machines provide the ability to host and manage your own virtual machines. What you use the VM for is largely your responsibility and your desire. And this includes using it to install, configure, and manage your own SQL Server VM or cluster of SQL Server VMs, which is going to be away from the platform as a service. When running your own SQL Server deployment on Azure Virtual Machines, you must understand three important cost factors. First is the cost of the Windows VM itself. Recall the Azure VMs are charged on a per minute usage model. Second is the SQL Server license cost. When using a SQL Server image from Azure Marketplace, you will pay an additional per minute SQL Server license cost, which varies according to the version of SQL Server, whether that's a web version, a standard version, or an enterprise version. And also, the target size of the VM will play a role in the pay that you have to provide to Microsoft. Finally, you'll also pay for the Azure storage cost. Azure storage, specifically page blobs, is used as the persistence mechanism for Azure Virtual Machines disk. To summarize, the cost for SQL Server in Azure Virtual Machines can be represented as total cost equals Windows Server cost plus SQL Server license cost plus Azure storage costs. If you have your own SQL Server license, you can actually use that instead of paying the per minute charge associated with using a SQL Server license obtained from an Azure Virtual Machine image. In this case, you pay only for the Windows Server license and any related Azure storage costs. The ability to use your own SQL Server license is a feature of license mobility through Microsoft Software Assurance on Azure program. We can always find more information about the license mobility online under the pricing section of azure.microsoft.com. microsoft.com. When configuring SQL Server and Azure virtual machines, take into consideration the following. VM considerations. It is extremely recommended to at least use a DS2 VM or higher when you are using SQL Server Standard or Web Edition. For the Enterprise Edition, it is recommended to use a DS3 VM or higher. When it comes to the storage considerations, always use Azure Premium Storage. Remember, this is the storage that is being provided and backed up on an SSD rather than an HDD. If using multiple data disks to store database data and log files, disable GEO-replication because consistent write order across disks is not guaranteed and it's going to cause errors for you. About the disk considerations, it is recommended for you to use at least two P30 disks, one for log files and one for data files. Remember not to store database data and log files on just the D drive. The D drive is a physically temporary disk and is not persisted in the Azure Blob Storage. However, if you're using a D-Series or G-Series VM, you might consider storing the tempDB database on the D drive. D-Series and G-Series VMs use an SSD drive for the D drive, and thus tempDB performance could be improved. For workloads that exceed the I/O per second limit for a single data disk, you may attach multiple data disks up to the maximum allowed by the Azure VM size and use disk stripping as a way to increase the I/O per second. For a comprehensive review of performance best practices for SQL Server and Azure virtual machines, you can look under the documentations of the azure.microsoft.com. Most of the high availability and disaster recovery or HADR solutions you might run for on-premises SQL Server deployments are also available when running SQL Server in Azure virtual machines. But why do you need to be concerned about the HADR for SQL Server in Azure virtual machines? As discussed before, Azure provides high availability features for the virtual machines, but not necessarily for SQL Server running on that virtual machine. It is possible for the VM to be online, but the SQL Server instance to be offline, unhealthy, or even both. Additionally, it is possible for the VM to be unavailable due to the hardware failures or software upgrades, which in this case, a practiced HADR strategy should be considered. SQL Server in Azure virtual machines support many of the same HADR technologies that are available for on-premises SQL Server deployments, some of which are always on, database mirroring, log shipping, and backup to and restore from Azure Blob Storage, which actually is available in SQL Server 2012 and SQL Server 2014. Depending on the technology used, it might be possible to establish a hybrid topology to allow the HADR technology to span between an Azure region and an on-premises data center. Some options, such as SQL Server Always On, allow for topology that can even span multiple Azure regions. Remember, you can always find more information on how to configure various HADR solutions under the documentation of the azure.microsoft.com. Just go there and look for HADR. The decision to use SQL database or SQL Server in Azure virtual machines can be difficult. On one hand, SQL database is ideal for reducing the administrative costs and provisioning and managing relational databases because many tasks such as upgrades, patching, backups, and business continuity scenarios are handled automatically. On the other hand, SQL Server and Azure Virtual Machines provides the option to migrate or extend existing on-premises SQL Server workloads to Azure. Even though there are additional administrative costs with running SQL Server and Azure Virtual Machines, the ability to maintain fine-grained control over those takes basically a better option and makes them a better option for the admins. Although SQL database and SQL Server are similar in many areas, some key differences exist. Most notably, SQL Server features that are not currently supported in the SQL database, such as the following: Windows authentication, file stream data, database mirroring, extended stored procedures, SQL Server agents/jobs, SQL Server Reporting Services or SSRS, and SQL Server Integration Services or SSIS, which are not supported. Alternatively, run a SQL Server on-premises or in the Azure VM and connect to a SQL database. The other not supported feature is the T-SQL features. Use a statement is not supported. To change database, a new connection must be established. Common Language Routine or CLR is not supported. Cross-database queries using 3 or 4 part names are also not supported. The limitations listed on this slide are only a few of those of which you should be aware when working with SQL database. For a complete list, please check the documentation under azure.microsoft.com. You can also find information on the MSDN website about this. There are many factors to consider when choosing between SQL database and SQL Server and Azure Virtual Machines, such as database size, existing application versus new application, level of administrative control, including hardware infrastructure, business continuity strategy, and hybrid scenarios, just to name a few. SQL database is often the right solution for cloud-designed applications that are not using unsupported features and for which near zero administration is a key priority. SQL Server in Azure Virtual Machines is often the right choice for new or existing applications that require a high level of control and customization, that is, full compatibility with SQL Server, and for which there is a desire to no longer maintain on-premises hardware. There are many database options available in the market today. The Microsoft Azure platform makes it easy to run a wide range of popular databases. You don't have to run SQL database or Microsoft SQL Server as discussed before. You can run the software of your choosing on an Azure VM, including the database platform you desire. You also have the option to run MySQL as a service via Microsoft's partnership with SuccessBricks ClearDB offering. If a relational database management system or RDBMS is not what you are after, using a NoSQL service such as DocumentDB or Azure Table Storage is also an option. Another popular relational database is MySQL. Microsoft has collaborated with SuccessBricks to bring SuccessBricks ClearDB database as a service for MySQL to the Azure platform. To get us started, open the Azure portal and click the green New button in the upper left corner. From the Data plus Storage category, find the MySQL database feature in the list of available services as shown here. You can also use the search option of the Microsoft Azure portal in order to find the MySQL database. Look at the screen and you can see what should you expect as soon as you click on that. When the new MySQL database blade opens, as you can see here, you'll have the opportunity to provide the necessary details about your new MySQL database, including the following. You can add a database name, which is the name for the new database, the subscription, which is the desired Azure subscription of yours, database type, select shared for lightweight database workloads and dedicated for a premium tier database hosted in single tenant clusters. The resource group gives you opportunity to select an existing group or create a new logical group where the new MySQL database will reside in. Resource groups are helpful for grouping related Azure resources. Location is the desired Azure region, and the pricing tier is where you can select one of the available pricing tiers. These tiers are not related in any way to the SQL database tiers or performance levels. Finally, you have the legal terms to choose from. Simply agree to the legal terms, which detail that the service is provided by SuccessBricks and not Microsoft, basically informing you of who is behind the service, and then you can continue. When finished, click the blue Create button at the bottom of the blade to submit the request to create the new MySQL database. Once the database is created, the database blade will automatically open. Clicking the Properties option on the setting blade will open a new blade, as you can see on this slide. This allows you to view details about the new MySQL database, such as the full host name, username, password, connecting string, and more. Remember, you're going to need the connecting string if you actually want to connect to this database through a code. Furthermore, the Azure Marketplace provides numerous additional databases. Those numerous additional database options, such as MongoDB, Vietnamese SQL, Vietnamese MySQL, and the DataStax Enterprise, as seen in this list, are all available to be hosted using Azure virtual machines. So, no matter what you really want to run, Microsoft is letting you do that on your Azure instance of virtual machine, regardless of if Microsoft directly is supporting those or not. You don't always need a relational database. If you don't need a relational database management system or RDBMS, which basically is based on the data storage solutions such as SQL Database or SQL Server in Azure virtual machines, then you are free to go and choose from any of the NoSQL options. The two very familiar NoSQL options within Microsoft Azure systems are DocumentDB and the table storage. DocumentDB is a fully managed, highly scalable NoSQL document database service available on the Azure platform. DocumentDB is designed to natively support JSON documents, and it automatically indexes all JSON documents added to the database. You use familiar SQL syntax to query the documents. This is one of the major reasons that DocumentDB is so popular amongst the programmers which come from the legacy systems. For more information on DocumentDB, please check the Services tab of the azure.microsoft.com. Next is table storage. Azure Table Storage is a cost-effective, highly scalable, key-value NoSQL store available on the Azure platform. Table storage is capable of storing up to 500 terabytes per storage account, with a single subscription supporting 100 storage accounts. Table storage is a semi-structured NoSQL data store that uses two keys, a partition key and a row key, as the primary composite index of the table. For more information, I'm referring you back to the account storage video that we reviewed a couple of weeks ago. For even more information, check the documentation under azure.microsoft.com. This will conclude this video. Thank you for watching and have a good one.